1.5, we're gonna talk about shifting, reflecting, and stretching graphs. First, I wanna know what type of function is this?
F of x equals x.
Great, what type of function is that?
A linear.
A linear function.
Yeah, Tyler.
What type of function is this?
Absolute value because of the absolute value.
Absolute values.
Yeah, Cameron.
What type of function is this one?
I have to get some motion this
Cubic.
Cubic.
Go back to the bathroom.
What type of function is this?
Square root.
Wait, no, it's not.
It's a square function, yeah.
Oh, yeah.
Square root, square function. What is this?
Parabola.
Parabola.
Parabola. That's the only thing I.
And what is this?
Rational.
Rational,
Right.
yeah. Yeah.
Yeah.
So we're gonna also,
You
you're
need me
also
to look in
here,
my book.
this one will also be called radical. Could be either, okay. Now, you're going to have to be able to, thank you, shift and stretch and reflect all of these types of graphs, okay? So, for vertical and horizontal shifts, there are 4 things to follow. If it is a vertical shift, it's C units up, you're adding C to the outside of the function. Okay, so it's a constant being added to the function. If it's going to vertical shift down, then the constant is being subtracted from the function. If you have a horizontal shift where it is C units to the right, that's where it's inside of the parentheses with the X, minus, okay? It's always opposite, so if it's going to the right, it's minus. If it's going to the left, a horizontal shift to the left, it's plus. When you're doing horizontal, it has to be in parentheses with the X. When you are doing vertical, it's on the outside of everything, and it's the constant that tells you what's happening. So on your homework, you're going to do a lot of graphing by hand tonight, because you're going to graph the parent function, and then you're going to shift it up, down, left, right, stretch it, shrink it, whatever it is that you're doing, okay? So here's the parent function of a cubic function. If I want to graph the function x cubed minus 1, how would I shift this function to graph that function?
Multiplied by the power shift.
It is a vertical shift.
Oh, you're so smart. So you shift everything 1 down.
He knows that because the 1 is not in parentheses. Yes. So I shift this down 1, and then everything else just basically goes from there, right?
Yes, ma'am.
So it's like this, basically.
No. Are we trying to make perfect graphs tonight?
No, not perfect graphs. If I can tell the points that you know definitely, if you shift all those, then I'm fine. Okay. Now, what about this one here? G of x equals, parentheses, x minus 1 cubed.
Now that is a horizontal one.
It is, and you are shifting it to the right. Good, Leighton. So I'm shifting it 1 unit this way, and it would look like this. Okay. Now, over here, you are going to have to write equations looking at graphs. So that's why you need to know all the parent functions and what they look like. Because if I want to write an equation for this, then I need to know that this is what type of equation? A parabola, which means what's my highest power? A square, good. Alex will do well. So these are pretty easy and basic parabolas, okay? What is the shift on this? My equation would say f of x equals what? Yeah, f of x equals x squared plus 4, because it shifted 4 units up. The vertex only changed by moving it 4 units up. Now this parabola, how would I write that one out? F of x equals parentheses. Parentheses. What happened to this?
We moved it 2 to the left.
Okay, so x
Minus.
plus 2. And then I square it. And then what else did I do with it?
Moved it down.
So minus 1. So you're going to have to look at graphs. You're going to have to write the equation of the graphs. Okay? That's probably going to be the trickiest part. The shifting I'm not too concerned about. I think you can do that pretty simply. Okay?
Wait.
Now,
I have a question.
what?
So, it went this way, right? So that's, if
You
it
did
goes
the
that way.
It's plus.
Plus, okay.
It's opposite on the x-axis, it's the same on the y is true to what it says. The x is opposite of what it says, okay? This is a, square function, a radical function. When you have a radical function, you're only graphing that first little portion of it like this. Why do I only graph a portion of a radical function?
So it's gonna come around.
Can I input, negative numbers into a square root?
No,
No, because then I have what type of numbers?
imaginary.
Imaginary. And so that's why we only show half of the graph, because we would have to have an imaginary axis, I can't talk, to do the other one. So this parent function for this should look something like that, okay? How do I shift it, in the pink with the negative on the outside? What does that do to that graph? What's the negative do?
Is it honestly not as scary as the one?
What does the negative do in a graph?
Keep going.
Nope, not thinner.
That's what it's like, you come out.
If I have a negative in front of any function, what does it do to my graph? You do flip it. You do flip it, Alex. And this section in the front will do well on the homework and everybody else won't because they're not paying attention. So I flip it like this. So that's that graph, okay? It just flips. What happens when I have that negative inside of the radical?
Then you have to do a plus and a minus.
You said you have to do a plus and a minus?
Yeah.
Okay.
You have to do
Possibly.
like two equations. Where is it?
Nope, not on these, Talia, not on these.
Oh.
Not when I'm doing, radical functions.
Would it flip to the other side of the graph?
Yes, it flips to the other side. So if it's on the inside, the negative, it flips to the other side like this, compared to the parent function, okay? So inside it flips over the y-axis, outside it flips over the x-axis, okay? And then what about this last one? What are we doing here? It's the outside and what happens?
Shift. Down. Sideways to right. Left.
There we go. We shift left 2 because this becomes opposite of what it is, and then it also flips down. So your graph looks like this. Okay.
Why would- oh, because it's negative.
Because it has a negative on the outside.
That's ugly.
I know, I just did all of them all in graphs. So here's the deal. If you want to do all of yours on a graph tonight, that's fine. You label them with numbers to tell me which number it is, or you do it in different colors. Okay? Save graph paper if you can, if it tells you to compare. That's what we're doing. That's all of 1-5.